Today we are going to finish out our unit with lesson 6-5, and it is over complex fractions. So a complex fraction just means it's a fraction within a fraction. And this is probably the more difficult section out of all of them, but it's really no different than what we've done before, as long as you can wrap your head around the fact that we're going to take, and if you look at example 1 down here, you want to get just one single fraction in the numerator and one single fraction in the denominator. And once you have that, so it looks like 1 or 2, you can see here in examples 3 and 4 how we don't actually we do have one single fraction here and here as well. Let's move to an example where you don't have that. So I think we have that on everything, but when we get to the back you won't see that. So it looks like it could be slightly complicated. It really isn't, as long as you can factor, you can find a least common denominator and all that stuff that we've been working on. So don't just look at it and close down and go, oh, holy cannoli, I don't know what to do. So here we go. We have a process. So this is something that should go on a daily flashcard. It's something that you should learn, study, know. So your steps to simplifying are going to be, as I said, create a single fraction in the numerator and a single fraction in the denominator. Then you're going to we're not really going to set up as a division problem per se. We are going to, and I would probably change this. We're going to change that to say keep, change, flip. Keep, change. I know there are people that hate that language, but for students it makes so much more sense. Keep, change, flip. Flip, flip. Okay? And then simplify. We might have to, and really basically you're going to factor and cancel diagonally and vertically, and then you're done. So let's go ahead and go through. I'm going to go through a lot of these examples just because I figure the more examples you have, the better off you are. So I'm going to make these really big so that you can see them and I have room to work. Okay, so our first step is to get one single fraction and one single fraction. So for this entire first page, the first step is done for us. So we're going to move on to step 2. We're going to keep. So this is where we're going to keep. I'm going to change this and I'm going to flip that. So keep, change, flip. However you want to write that out. So I'm going to keep the a over 2. I'm going to change division, because remember a fraction bar is division. I'm going to change division to multiplication. And then I'm going to flip this denominator. So they're just going to, I'm going to take the reciprocal. So I'm going to put the 4 over the a squared. Now we have all monomials. There's no addition or subtraction signs. So remember, I can cancel diagonally, right, or vertically. Or you could instead multiply straight across. So if I multiplied straight across and then you simplify, a times 4 is 4a, and then 2 times a squared is 2a squared. You can do it that way. I'm going to show you both ways. So the 2 cancels into the 2 and 4 once and twice. And remember, when you divide like bases, we subtract exponents. So this has an exponent of 1, and we subtract where there are more. So you are going to end up with 2 divided by a. Then we have to come up with restrictions. Remember, our denominator here can't be 0, so you're going to set that denominator equal to 0 and solve. Well, if I set a equal to 0, it's already solved. So a can be anything as long as it's not 0. So both parts have to go with your answer. You have to keep, change, flip, simplify, and then state your restrictions. Okay? So let's try another one. Oh, let me show you on this one how I would have done it diagonally, and this is the way I would prefer to do it personally. So I can cancel diagonally. If this is a to the first, this entire a to the first is going to cancel with one of those. This 2 divided by 2 is 1, 2 goes in here 2 times. And then you could have just multiplied 1 times 2 is 2, 1 times a to the first is a to the first. So that's the way you're going to see me doing it from now on, but if you prefer to multiply straight across, that's all up to you. So you go ahead and try 2 on your own, pause the video, and then restart. All right, so we are going to keep, change, and flip. So I'm going to keep the first fraction, 6 over xy, change that division bar to multiplication, and I'm going to flip the denominator's fraction. So find the reciprocal, so 8x cubed over 3y. Then I'm going to simplify. So I'm going to diagonally cancel the 6 and the 3, so 3 goes into 3 once, 3 goes into 6 twice. There's nothing that will cancel with the 8s. You cannot cancel horizontally, so the 2 will not cancel into that 8. But diagonally here, the x's cancel. So this is smaller, so I'm going to subtract it from this one. So this x is going to cancel with one of those. And then again, I cannot cancel the y's diagonally. We're going to just end up multiplying. So 2 times 8 is going to give me 16. And then I'm going to tack on the x upstairs here. So 3 minus 1 is 2, so I get an x squared divided by. And then in the denominator, I have y times y. So when we multiply like bases, we add their exponents, so I get y squared. The only thing in the denominator is my y. So if I set y squared not equal to 0 and solve for y, wouldn't I take the square root of both sides plus or minus the square root here, and wouldn't I get y cannot equal plus or minus 0, which is still 0. So then my restrictions that I'm going to add here would be y cannot equal 0. So here is my whole answer. All right, let's look at 3. So 3 looks a little bit more complicated, and it is, I will grant you that, but we're still going to keep, change, flip because we have one fraction over one fraction. So my keep is my 18p over 8p minus 2. And instead of a division bar, we're going to multiply, and we're going to take the reciprocal of the denominator's fraction. So the 4p minus 1 goes up top, and then 4p squared goes in the denominator. Then, instead of just multiplying, because if I just multiply and take this 18p and multiply it all the way over here, I'd distribute the 18p to here, and then we'd have to tear it apart and factor it. So I would prefer to factor all 4 parts separately. If it's a monomial, we're just going to keep it as a monomial, which is what they are. So 18p cannot factor because it's a monomial. 4p minus 1 has no greatest common factor, so it doesn't factor. So I'm going to put it in parentheses, showing that it's fully factored. However, my 8p minus 2 can be factored. I can factor out a 2. So if I factor out a 2 out in front, remember I'm going to divide each of these by 2, and if you want to show that, I guess you could. We'll just divide by 2, divide by 2. Then you're going to get 4p minus 1. 2 divided by 2 is 1. So this goes away and becomes 2 times 4p minus 1. And now I can diagonally cancel. So I can diagonally cancel this with this. I can choose either to vertically cancel the 2 into the 18, which is probably best. And I might then be able to cancel the 4 into the 18, but possibly not. So it's half a dozen one way or another. These two, you can divide them both by 2, and I can cancel a p with a p squared. I'll do that in a minute. Or I can cancel a 2 with the 18, but I can't do it to all 3. Okay, so it's 1 for 1. do 2 at a time. So 2 goes into 2 once, 2 goes into 18 9 times. That leaves me only with this p to the first canceling down here with one of those. Okay, so I have left in the numerator, I have a 9, no p's, none of this. So I just have a 9. That's all that's left in the numerator. In the denominator, this is gone, this is gone. I have a 4 and a p to the 1. So a 4 and a p to the first. Restrictions. You have to look at your original fully factored denominators, both of these, even if they canceled out. So we are going to take, let's see, I'm going to take, let me change some of my colors here. I'm going to take the 4p minus 1 and set it not equal to 0 because that's a variable in a denominator that could cause a restriction. I'm going to add 1 to both sides, so that gives me 4p cannot equal 1, and divide both sides by 4, so that gives me p cannot equal 1/4. So there's one restriction. Then I have this monomial of 4p squared, because that's my original before I canceled, cannot equal 0. If we were to solve, you're going to find that anytime you have a monomial, the variables in that monomial will not be able to be 0. So I end up with, because 0 divided by 4 is 0, and of course we would take the square root of both sides, plus or minus the square root of 0, and as I said, p is not going to be able to equal 0. So we have 2 restrictions here. P cannot equal 1/4, comma, 0. So those are actually going to create a restriction in a domain. So if p would have been in my domain, we can talk about how to write those if you want to, but for right now we're going to ignore that because you're going to see different variables in x and y. All right, so you go ahead and try 4 on your own. Don't forget that this k squared minus 1 can be factored. It's a special factor pattern. So pause the video and try that one on your own. Okay, so I've got one fraction equaling one fraction, so I'm going to keep the first fraction, change division to multiplication, and flip the denominator. So I get k squared up top and k squared minus 1 in the denominator. This k squared cannot cancel because you have subtraction outside of parentheses. You cannot cancel this k squared. You have to factor first before you can cancel. And you know that you fully factored everything if all of your addition subtraction signs are inside of parentheses. So this binomial cannot be factored, so I'm going to put it in parentheses. Monomials cannot be factored, so we're going to leave them alone. This, however, can be factored into, I'm going to take that away, and it can be factored into the difference of two squares factor pattern, and that's that plus minus pattern, where we take the square root of both of these and put them in the first and last terms. So the square root of k squared is k, and the square root of 1 is 1. So k squared minus 1 gets factored into k plus 1 and k minus 1. Okay, so then I can cancel diagonally as well as vertically. So diagonally, I can cancel a k minus 1 with a k minus 1, so 1 for 1, so those are gone. There's nothing for me to cancel this k plus 1 with, but monomials can cancel with each other. So this is k to the first, so it's going to subtract up here in the numerator. So this k to the first gets subtracted up here. So all I have left out of the numerator is just a k. And then all I have in this denominator, this is gone, so I just have a k plus 1. And I prefer to keep that k plus 1 in parentheses to avoid you trying to cancel this k with that k, because you cannot cancel a k with a k when you have an addition sign outside parentheses. In other words, if it looks like k over k plus 1, and you try to cancel those and say it's 1 over 1, which is 1, you can't do that. All right? you cannot cancel until you have addition and subtraction inside of parentheses, and now you can't cancel that k with that k plus 1. So be very careful that you're using proper reducing techniques. All right, so to get your restrictions, go back to your original fully factored denominator. So that's a factor, that k. So k cannot equal 0. So that's already solved, so that's one restriction. Then you have to set that one equal to 0. Cannot equal 0. And then if we subtract 1, k cannot equal -1 is another restriction. So there's 2. And this is another factor. Even though we canceled it out, it still is considered a restriction. So add 1, k cannot equal 1 is a third restriction. So we have 3 different restrictions. So k cannot equal 0, and then you can write this as plus or minus 1. So there's your whole answer. All right, so let's move to 5. Okay, so for 5, it's very similar to what we've already done. So let's do our keep, change, flip. So, and if you want to, while you're doing your keep, change, flip, you can go ahead and start to factor. So I know that this factors, I can factor out at 7. So I can pull out a greatest common factor of 7. And when I divide each term by 7, I get c plus 5 divided by c. So that's my keep. Change division to multiplication. And I'm going to flip the second fraction. Nothing can be factored in that second fraction. So that c plus 5 is not factorable, so I'm going to put it in parentheses. That way I can diagonally cancel a c plus 5 with a c plus 5. I can always cancel monomials with monomials, so this c is going to subtract up here because that's where there are more. And so we end up with a 7 here and a c in the numerator, so 7c, over, there is nothing left in the denominator, so that means that we have over 1. We don't write anything over 1, so it's going to be 7c with some restrictions. So this one, even though we canceled it, you have to set it not equal to 0, so there's one restriction. And then this one, c plus 5 cannot equal 0, so subtract 5, c is equal to -5. So we have 2 restrictions, c cannot equal 0 or -5. So as we move over to number 6, it does start to get a smidgy bit more complicated, but again, don't let that bother you. You should be fully mastered in the art of factoring. And so here we go. We have 1 fraction over 1 fraction. It's just a very complicated fraction over a complicated fraction, which makes a very complicated fraction, but we're going to keep, change, flip. So we're going to keep the numerator, and I'm going to factor as I go. So this numerator cannot be factored. So I'm going to put it in parentheses, b plus 2 over, and then this denominator can be factored. And you're going to find in this section that the factoring for your trinomials tends to be fairly simple. So we don't have a coefficient here, so the factors of 8 that add to give you 6 are 2 and 4. So I've got b plus 2 and b plus 4. I know that the signs are positive because all the signs are positive in that denominator. Then we're going to change division to multiplication, and then we are going to flip this fraction. So this denominator here can be factored. The factors of 20 that subtract to give you 1 are 4 and 5. Let's talk about the signs. Whoops, I want that to be black. So b and b. And then we have a 4 and a 5. Since my middle term is negative, I want the bigger of the 2 to carry that sign. The 4 is going to have to be positive to combine with the 5 to make a -1. And then it's over 1. So now I can cancel diagonally and see now it's a piece of cake. I can also cancel vertically. So because the b plus 2's are vertical, I can cancel those. And the b plus 4's are diagonal to each other, I can cancel those, so long as I cancel one thing in the numerator with one thing in the denominator. That leaves me only with b minus 5 over 1. So that means that my answer is b minus 5. I will keep that in parentheses just because we also have to do restrictions. So for our restrictions, I'm going to take our fully factored denominators. So I'm looking only at the denominators here. And I'm going to set the b plus 2, even though it was canceled, not equal to 0. And the b plus 4, not equal to 0, and solve. So here I would subtract 2. So there's one restriction. And here I would subtract 4. Whoops, I'm not going to actually physically subtract it because we can do that one in our head. And there's our second restriction. So our restrictions here are going to be b cannot equal negative, I don't know why I put a parentheses or a comma first, that's weird, negative 2, comma, negative 4. So all of this is my answer. So I went from a complex fraction to something fairly simple. All right, let's move on to 7. As I said, I'm going to do a lot of examples so you get that practice. Now on number 7, because each one of these has something different about it, this is not a fraction, right? But I can make it into a fraction by putting it over 1. Okay? So I'm going to keep, change, flip, and I'm going to factor as I go. So for this numerator, the only thing I can do is factor out a greatest common factor of 15. So 15 times, and if I divide each of these by 15, 15 divided by 15 is 1, and then the second term you're going to have just a minus r, over, and then that monomial I can't factor, so over 15r squared. We're going to change that division bar into multiplication. And then we're going to flip this denominator. And so that's why it was important to take a non-fraction and turn it into a fraction, so that when I took its reciprocal, you can see that it's going to be 1 over, and then we're going to factor 12r minus 12. So they have a 12 in common. So I'm going to factor out a greatest common factor of 12 and divide each of those by 12. So 12r divided by 12 is r, minus 12 divided by 12 is 1, so it doesn't disappear. So this creates an interesting situation where I have a 1 minus r and an r minus 1. So let me ask you this. And whenever you have a situation where they look very similar, but the terms are reversed and you have a negative sign, what if instead of factoring out a 15, I had factored out a negative 15? What would that have done here if I divided this by a negative 15? What would I end up having? A positive 15 divided by a negative 15 would have given me a negative 1, right? And then here, a negative divided by a negative is going to give me a positive. The 15s would cancel, and wouldn't I have a positive r? Isn't a negative and a negative and an r, couldn't I rewrite this so it's r minus 1 so it looks just like this? I can. So I'm going to rewrite this so that it's really r minus 1, but I want to make sure that that negative is taken out. So note to self, you might want to highlight this, star it, something. Whenever you have this situation where they're reversed, you can fix that by factoring out a negative, and then it reverses the signs, and you can change those terms. So now I can actually cancel diagonally this r minus 1 with this r minus 1. And I can cancel the 15 with the 15. Notice that the negative does not cancel. And I don't have anything to cancel with the r and nothing to cancel with the 12. So up top I have a negative. All of this is gone times a 1. So in my numerator, I actually have, a negative 1 over, and then I'm left with an r squared times 12. So I'm going to put the 12 in front, 12r squared. Then let's look at our restrictions. So for this one, right, anytime we have a monomial, the restriction is going to be the variable cannot equal 0. So again, one more time, I'm going to show you that if I were to solve for r, I would divide by 15. This is the last time I'm going to go through this. I get 0, right, and then I'm going to take the square root of both sides and plus or minus the square root of 0, and that gives me r is equal to plus or minus 0, and we should have does not equal through there. And then 0 doesn't have two signs, so it's just r equals 0. Even though they're canceled, we still have to find restrictions. And then this one, we just have to set the r minus 1 not equal to 0. We would add 1, and r cannot equal 1. So our restrictions are r cannot equal 0, 1. Done. Okay, let's finish up the last problem on this page. And it gets a little hairy, but not too much. So this numerator, I can factor out a 2. So I'm actually going to start that first. So if I factor out a 2, I'm going to change all of this to a 2 times, right? And if I divide each of those by 2, I get m squared. Negative 2 divided by 2 is negative m. Negative 40 divided by 2 is negative 20. So the 2 doesn't go away, right? So it's still out in front, so I have a 2, and then I'm going to factor that trinomial right here. And we just factored that before. The factors of 20 that subtract to give us 1 are the 4 and 5. So I have an m and an m, and a 4 and a 5. My 5 is bigger, so it carries the sign of the middle term, which is negative, and that means the 4 is going to have to be a positive. Over. And then in this denominator, because we're going to keep, right, so this doesn't change any positions, the 3m and the 12 have a 3 in common. So I'm going to factor out a 3 and divide each term by 3. So 3m divided by 3 is m. 12 divided by 3 is 4. Then change, so the division bar changes to multiplication, and we are going to flip this fraction. So I'm going to start with this numerator first. It has a greatest common factor of 9m. So I'm going to pull a 9m out, and I wrote that there on purpose so you could see what I was doing. So a 9m comes out in front, and then the 9's are going to cancel. M squared divided by m is just m, right? And then here, 36 divided by 9 is going to be 4, so plus 4. And then the m's will cancel. So that's that denominator factored. It now becomes our numerator. And then over here, these have an m squared in common. So I'm going to divide each of these by an m squared, right? And don't forget that that m squared has to come out in front of parentheses. So here, m cubed divided by m squared is just m. And then these are going to cancel, right? So I'm left with just a minus 5. Okay, so there's my keep, change, flip. Now I can cancel diagonally and vertically. So vertically, these two will cancel. Diagonally, I can cancel an m minus 5 with an m minus 5. Then for my numbers, I can diagonally cancel the 3 and the 9. So 3 goes into 3 once, 3 goes into 9 3 times. And then I can always cancel a monomial with a monomial, right? So I can cancel this m with that m squared. So there are more m's in the denominator, so that m is going to get subtracted from that one. That's a subtraction, it's not a multiplication. Okay, so then what I have left up top is a 2 and a 3 and an m plus 4. So if I multiply those together, 2 times 3 is 6, and then times an m plus 4, all divided by, all I have left in the denominator is this m to the 2 minus 1, which is m. You cannot cancel these m's here because this is inside parentheses and that's outside. So that becomes your final answer besides restrictions. And so here comes our restrictions. So this has a variable in it. So we're going to set m plus 4 not equal to 0. if you subtract 4, you get m cannot equal -4. So there's one restriction. This is a monomial. We all know that monomials restrictions means that m just cannot equal 0. I've done that a couple of times here, so I'm not going to go through the whole thing. And then this one also, m minus 5 minus cannot equal 0, so m cannot equal 5. So we have 3 restrictions. So m cannot equal 0, -4, and 5. Doesn't matter what order you put them in. Done. All right, so let's flip to the back of your paper and start to look at some more complicated items. So we're only going to do 4 on this page, but I will go ahead and give you just the answers to everything else so that if you want to try them, you can check them, and if you're not getting the right answer, you can ask me for help. So we are going to start with number 9. And I'm going to make this really big so I can show my work and have lots of room. Okay, and you can see it. And I'm going to make it straight because it's not. All right, so this whole back has fractions that you don't have one single fraction up top and one single fraction on the bottom. So one of our first goals is to simplify this so I have just one fraction. So we have to get these over the same denominator like this one is. So if I look at these, oftentimes it's just easiest for you to just multiply these together and say, okay, my least common denominator is going to be 3 times x, which is 3x, okay? When we get to some other more complicated factors, I'll explain that. But if I want my LCD to be 3x, that means that this one's missing in x. So I'm going to want to multiply that by an x. Whatever I do to the bottom, I have to do to the top. Well, the second term, this x is missing a 3 for it to look like a 3x. Whatever I do to the bottom, I must do to the top. So I end up with x times x, we're right here, x times x, and 3 times 3. So x times x is x squared, minus 3 times 3 is 9. We'll factor that in a minute. All over, now they're over the same denominator, so I can combine them as one fraction. All over x minus 3 over x. Don't try to cancel anything until you've fully factored everything. So now we're going to keep, change, flip, and we're going to factor each numerator and denominator as we go. So remember, this numerator is the difference of 2 perfect squares. You need to know that pattern, and that pattern is a plus minus pattern. So you take the square root of x squared, which is x, and that goes here, and the square root of 9, which is 3, and that goes here, and that's all over a 3x times, instead of the division bar, and then we're going to flip that. So the x goes in the numerator over, and the x minus 3 cannot be factored, so it stays in x minus 3. Now it's just like we did before. I can cancel the x minus 3 with the x minus 3, and I can cancel this x with that x. That leaves me with just an x plus 3 in the numerator and just a 3 in the denominator. You really need to leave the x plus 3 in parentheses, because otherwise you might be tempted to cancel the 3 in this denominator with the 3 up here, and you cannot do that. So now we have to look at restrictions. So my restriction for 3x, remember, it's a monomial. All monomials, the variables in all monomials cannot equal 0. So there's one restriction. And then here, x minus 3 cannot equal 0. Add a 3, x cannot equal 3. So those are our 2 restrictions. So x cannot equal 0 or 3. Those would actually create asymptotes. Since this is an x, I feel like I can talk about that. This would create an asymptote, a vertical asymptote at x equals 0 and at x equals 3. So this would actually be an interesting looking graph. Lucky for you, you don't have to graph it. So then I'm going to move on to 15. And before I move on to the other two, I'll give you the answers to 10 and 12, but let's do 15 first. So for 15, I have one fraction in the numerator, great, but I don't have one fraction in the denominator. Before, and this is a more complicated denominator than the last one, so before I can find the least common denominator, I have to have all of my factors, so it has to be fully factored. This one's fully factored, this one is not. So this one I'm going to put in parentheses. Okay, but this one, the second one, I can factor a 4 out of each of those terms. So it becomes 4 times 4n divided by 4 is n. Negative 16 divided by 4 is negative 4. So that one gets replaced with this. Now, they both have an n minus 4, which is great, but this one has an extra 4 that this one does not. So you want them both to have the same factors raise the same exponents. So since they both have the same amount of n minus 4s, we're good. If one had more than the other, you'd have to add, or really multiply, the one that's missing it by however much it needs. Well, they're not missing n minus 4s, but this one has a 4 that that one doesn't have, so we have to be fair and give this one a 4. If I multiply the denominator by a 4, I have to multiply the numerator by a 4. So we end up getting 5 over 4 all over 4 times 20 is 80 minus 5 all over the same denominator 4 times n minus 4, because I just created like denominators, so when I multiply this, I can just combine them over the same denominator as one fraction. So of course we will combine this here in a minute when we do keep, change, flip. So this should be pretty easy to do keep, change, flip with. So as you can see, once you get the numerator and denominator into single fractions, your keep, change, flip tends to be pretty simple. So here we go. Whoops, let me change to my colors. So I'm going to keep the 5 over 4, change the division bar to multiplication, and flip the bottom fraction. So I get 4 times n minus 4. And then my denominator, instead of writing 80 minus 5, I'm going to write 75, because I can perform that math. Now we're going to cancel diagonally. So diagonally I can cancel the 4 for the 4. And 5 and 75, I can divide them both by 5. So 5 goes into 5 once, 5 goes into 75 15 times. And that's all I can cancel. So in the numerator, I have left an n minus 4, and in the denominator, a 15. Leave that n minus 4 in parentheses over 15. Then comes our restrictions. So, do we have any restrictions? No variable here, no variable here. So we are good to go. Now, some might argue, and I could argue this too, that you should look at this before we keep, change, flip. And so, because this is in a denominator, so if we looked at this fraction here and n were 4, then we would have a 0. So you could argue the point that n should not equal 4. We're not going to go that far, so we could just leave that as our answer. Okay, so then your answers, in case you want to try these on your own, for 10, your answer for 10 should be 1 over q minus p. And so that one's going to be a weird restriction because you've got two different variables in that denominator, so don't worry about your restrictions on this one. And then your answer to, oopsie, I don't want that. Then your answer to number 12 will end up being simply just w over 2. And again, you could argue your restrictions as w cannot equal negative 2, or possibly, and I haven't looked at, let me look at the work here, yeah. So your restriction should be w, you can't argue it, your restriction definitely should be w cannot equal negative 2. Okay, All right, so we are going to go ahead and skip to 14 and 16 and we'll be done. I will give you the answers to 13 and 15 as well. All right, so we need to get these, both of them, into one fraction. Anytime you have 1 as one of your terms and you're trying to create it into a fraction, remember I can take 1 and change it into a fraction by putting them over 1. And then you can see we only have one denominator here, which is n. This one doesn't have that, so it's missing it. So I need to multiply it by what it's missing that the other one has. So if I multiply the denominator by n, I have to multiply the numerator by n. Same thing in the denominator. This fraction has an n, this does not have it. So it's missing an n, so I'm going to multiply it by n. What I do to the bottom, I need to do to the top. So I end up with, in the numerator, m minus 1 times n is n, all divided by, now they have a common denominator of n. So I can put them over the same denominator as one fraction. In the denominator, we have m plus 1 times n is n, all over the same denominator of n. Okay, so now we're going to keep, change, flip, and factor at the same time. This cannot be factored. They don't have a greatest common factor. It's not the difference of 2 squares or 2 cubes. Same thing here. Can't be factored. You can't factor the sum of 2 squares, and it's not that anyway. And you can factor the sum of 2 cubes, but it's not that. So we are going to put this in parentheses and this in parentheses because I don't want you thinking you can cancel those n's, because you can't. So keep, change, flip. M minus n, we're going to keep this all over n, change your division to multiplication, and then we are going to flip that fraction. So we get an n in the numerator and an m plus n in the denominator. Then I can cancel diagonally, so I can cancel an n for an n. I cannot cancel these. They are not exactly alike. This has a minus, that has a plus. So my final answer is going to be m minus n, notice I'm leaving it in parentheses, over m plus n. Let's talk about restrictions. The restrictions on this one are interesting. So as I look at my original denominators, this right here means that n cannot equal 0. When you have 2 variables, like this one, m plus n cannot equal 0, you have to decide whether you're going to solve for one variable or the other. So I'm going to choose to solve for m. If I solve for m, that means I would subtract n from both sides. That would leave me with m cannot equal a negative n. In other words, if m and n were the same number but opposite signs, wouldn't that create a 0? Like if m were 2 and n were negative 2, that would create a 0. So we can't have them being the same number and opposite signs. And that's essentially what this is saying here. So our restrictions look a little different. We're going to have 2 separate ones where n cannot equal 0 and m cannot equal a negative n. Now you could have chosen to solve for n, and if you had solved this for n, you would have just had n cannot equal negative m. And so you could have had n cannot equal 0, comma, negative m. Either one is acceptable. Okay, last problem, and then I'll give you the answers to 13 and 15. So this one looks like it's the most complicated of all, but again, we're just going to apply everything that we've done. So to combine this fraction here into one denominator, I need to factor the denominators to see what factors each has and what factors the other one is missing. So this one cannot be factored. So a plus 3 is the only factor of that first denominator. However, this one here, they both have a 5 in common, right? So I can, and I'm going to rewrite this one so that I have a 5 times, if I divide each of these by 5, so 5a divided by 5 is an a. And then 15 divided by 5 is a positive 3. So that is the new factored denominator here. Notice that they both have one a plus 3, So I don't have to multiply them by that. But this one has a 5 that one is missing. So since the first fraction is missing a 5, I want to multiply it by a 5. But whatever I do to the denominator, I have to do to the numerator. So then that is going to leave me with a 5a squared plus an a squared, we'll deal with that in a minute because they're like terms in the numerator, all over the common denominator of 5 times a plus 3. You want to leave your denominator fully factored because remember we're going to keep, change, flip, and cancel based upon fully factored numerators and denominators. Okay, so look at the next denominator. A plus 3 cannot be factored, and neither can the 5. So this has an a plus 3. That one's missing an a plus 3. So since the second fraction is missing an a plus 3, we better multiply it by an a plus 3 so they both have the same thing. What I do to the denominator, I have to do to that numerator. Also, they're still not balanced. This has a 5 and an a plus 3. This one's missing the 5. So I need to multiply it by what it's missing. What I do to the denominator, I have to do to that numerator. So I get 5 times a is 5a plus 1 times a plus 3. So I'm going to go ahead and remove the parentheses here because I'm going to have to combine like terms of that 5a. And if that were anything but a 1, like if it were a 2 or a 3, I'd have to make sure I distribute, okay? So I end up with a plus 3 all over the common denominator of 5 times a plus 3, okay? We are not ready to keep, change, flip yet. So let me simplify those numerators. Because these are like terms and the coefficient here is 1, I have 5 of these things plus 1 of these things gives me 6 of those a squareds all over the fully factored denominator of 5 times a plus 3. All over, collecting like terms here, I can collect the 5a with the a. So 5a plus a is 6a plus our 3. It doesn't have anything to combine with. All over our fully factored denominator. Now, we might be able to factor our new numerators here and here based upon what we just did. This is a monomial, it won't be factorable, but this, don't they have a 3 in common? So when we keep, change, flip, we're going to factor at the same time. So the first fraction, the top, the part we're keeping, nothing can be factored because we've already factored everything that can be factored. So that's a 6. I know it looks like a b. So 5 times a plus 3. Instead of division bar, we're going to change that to multiplication. And then we're going to flip this fraction and a factor. So the 5 times a plus 3 goes up top. It's already factored. And then we are going to factor out a 3 from here. So we're going to divide this by 3 and divide that by 3. And so we're going to have a 3 out in front. 6a divided by 3 is a 2a. 3 divided by 3 is a 1. Okay, now we're ready to cancel. I can cancel the a plus 3 with the a plus 3 because they're diagonal. I can cancel this 5 with that 5. They're diagonal. I can reduce the 6 and the 3 by dividing both of them by 1. So 3 divided by 3 is 1. 6 divided by 3 is 2. I don't have anything to cancel the a squared with or the 2a plus 1. So we are left with a 2 in a squared up top and a 2a plus 1 in the denominator. So we get 2a squared in the numerator and then 2a plus 1 in the denominator that we're going to leave in parentheses so you don't try to cancel the 2's or the a's because you can't. Now, we can look at restrictions. So if we look at the restriction here, a plus 3, if you set that not equal to 0, you would subtract 3. So a cannot equal a negative 3, comma. And then if you set this not equal to 0, you would subtract a 1 and divide by 2. So a cannot equal a negative 1/2. Done. Now let me give you the answers as I promised to these two so that you could do them if you wanted to. So the answer to this one is going to be b minus a in parentheses over ab. And it is possible, or you could have a negative out front. Most of you will not choose to do that, and you could have a minus b over ab. Either one's acceptable. Your restrictions on this are kind of weird. On either one of these, your restrictions are going to be a, let's see, so a and b will not be able to be 0 because they're in your monomials, right? And then the other thing is that a cannot equal a negative b. All right, and then 15. 15 is going to end up equaling v plus 1 all over v plus 4 or 4 plus v. It's up to you, but I'm going to write it as v plus 4 because it's addition. And then your restrictions would be v cannot equal 0 or negative 4. All right, so it's going to be a harder homework, but please try. Ask lots of questions. Good luck.